My name's Scott Titterman and I'm the Global Sales Manager for Petrosys, which means that I work with our 300 odd customers around the world to make sure that they get the most out of their Petrosys implementations. I've been involved in the oil and gas industry for more than 15 years now, and a significant proportion of my time has been spent working with customers and with E&P companies on data management solutions. And today's webinar is focused on data management, and we're going to have a chat about how we've been working with 2 or 3 customers to bring some data management solutions to the challenges that they've been having. And this should be illustrative to you of some of the problems and challenges that Petrosys help organisations to resolve. Before we get into that, just a couple of matters for housekeeping. Firstly, to let you know that this webinar is being recorded. Also, that the data that I'm going to show during the demonstrations of the products and the solutions isn't real client data for confidentiality reasons. It is, however, illustrative of the project deliverables. The other is that in your GoToWebinar panel, there's a block which allows you to ask questions. And I would encourage you to do that as the presentation goes along. What I will do is keep the flow of the presentation moving along and come back at the end of the presentation and answer all of the questions which have been asked as the presentation has continued. As I said before, I have the privilege of being able to work with many different customers around the world. And when I chat to customers about data management, I usually start the discussion by asking them this particular question. And I'm not going to ask it of you today, but I assure you I often get very interesting and descriptive answers to this particular question. What I thought I would do is share with you some of the most common responses to this particular question. Many customers will continue to talk to us about data being in silos within their organisation. In other words, data still existing within a given application or a given asset or workflow and having difficulty exchanging that and sharing it amongst different business units or users within their environment. Many customers will talk about the challenges of uniquely identifying their E&P and geoscience assets, things like wells and seismic and permits, or dealing with multiple versions of data which are created and managed in their organisation through time, or indeed the volume of data which is created. Many folks still grapple with the challenges in dealing with project-oriented data repositories and data sources, and the context that projects, which are the development of assets, also have a life cycle and different objectives. Many people see the opportunity to improve data quality, to work with data more effectively from multiple sources, and to improve in their organisation the ability to find data, report data or share data. If you ticked any of those boxes, the first point I'd like to make today is that firstly, you're not alone. There, as I said, many organisations deal with these challenges. And the second point that I'd like to make is that when you begin the journey of improving data management in your organisation, it becomes a program, meaning that as you begin to improve data management in certain aspects of your organisation, and as your organisation and your assets evolve, so do the challenges that you face, and not only the challenges that you face, but the opportunities that you have to improve the way that data works within your organisation. I guess the bottom line here is that data is such a fundamental part of the way that geoscientists and engineers in E&P companies make decisions, that it's an important thing to improve, that being the data quality or the way that data is managed in the organisation, and thus the investments in improving data management are very valuable to organisations of all shapes and sizes. The second trend or group of trends that I wanted to share with you relate to this different spectrum of data that we see in organisations, that being seismic or geophysical knowledge or petrophysical and well-orientated data through to drilling, production, and reservoir engineering. I guess it's true that in all organisations that we visit, there is a broad spectrum of data, and what we also notice is that the importance and the effectiveness of working with this data is different in different organisations, and it's also different depending on the status of a given asset life cycle. But there is a broad range of data, and different users of data want to use data in different ways. It also continues to be true throughout the 15 plus years I've been involved in the industry that organisations typically tend to have multiple applications, and we don't see this going away in the industry. In fact, it continues to be one of the challenges in working with data. And whether the list of applications which are shown here is exactly the list of applications in your organisation or not, it's certainly true that many applications are used. And there's a really good reason for this. Organisations want to provide users, geoscientists, with the most effective tools to resolve the certain challenges that they're facing, and different data and different asset life cycles and users need different tools. This creates with it obviously the challenge that there are different project and data environments which are created. But this is certainly a trend in the industry and one that we see continuing right throughout different organisations. Again, continuing in the industry, we see organisations wanting to implement master data stores as part of their E&P and geoscience data management strategies. I want to share with you some of the reasons and the business values that we see or we hear are the reasons for the implementation of this type of component in a data strategy. Organisations find that it provides them a unique reference for their assets, that being their well knowledge, their surveys, their fields, their permits. It allows companies different ways to tie data together that might be in a master store or in various parts of this project or this data life cycle. In the process of implementing master data stores, organisations often look at the procedures and the practices and the governance and stewardship of the way that data flows both into a master data store, into project environments, between project environments, and as results of different projects and interpretations are created, ideally back into their master data environment. Master data stores give organisations a place where they can represent the gold or the highest quality level of data, provide access and push data to applications and users, manage data from various versions and sources and interpretations, and also a way to publish information. So the rest of this particular webinar is going to focus on this spectrum of data, the challenge of working with information in many different project repositories, and also how to relate a master data store as part of your data management strategy. What I'd like to share with you is a few bullet points of how Petrosys helps in this type of environment. Firstly, Petrosys works with customers to establish and maintain PPDM-oriented master data stores, and the PPDM being an open, vendor-neutral industry standard. And you can read more about that at ppdm.org. Petrosys also works with customers who have existing master data stores and existing master data management strategies. We work with organisations who are looking for tools and ways to integrate data and transfer data, in particular between master repositories and project-oriented spectrum of data. And we do that, and we'll show you some of that in the solutions which are coming. One of the things that's true of Petrosys is that we work openly and collaboratively with many other vendors, and you'll even see some other vendor solutions apparent in this part of our data management strategy and the solutions that we're going to talk about. The Petrosys desktop mapping environment continues to be an important part of integrating data. It provides a way for organisations to directly access a spectrum of data down here in project land or in the application environment, but it also provides a way for users to directly access maintain, query and report information in a master repository. A core part of work that Petrosys does is to ensure that our geoscience knowledge is effectively integrated with spatial data management and spatial data within an organisation, and you'll see in the solutions the various ways that data can be imported, exported and directly published so that the integration of spatial and geoscience knowledge is effective for organisations. A lot of data in our industry isn't in databases, or it's in documents and it's in physical form. And one of the key challenges that we see many organisations dealing with is the ability to link both unstructured and structured data, and by that I mean data in data systems and databases, to that's in documents, library systems, asset management systems, and we'll see how that's possible through Petrosys in some of the solutions. In working with customers for the 15 odd years that I've been involved in data management, while some of the solutions and needs are common, the emphasis on different data, the different sizes of organisations, and even their existing application data landscape means that the solution that's implemented needs to be tailored. Trying to buy data management in a box is something which often doesn't work, and at Petrosys we've engineered an architecture which we feel is customisable and extendable in order to fit both with existing data environments and also with the different data emphasis and needs of clients. Whilst providing access to information on a desktop is important to geoscience users, there are a heck of a lot of users in organisations that need to access information in a web browser, distributed environment, and also in non-geoscience or geotechnical roles. And with that in mind, you'll see some of the work that we've been doing with web dbMap and the provision of corporate information, geoscience information in web-based environments. So it's these 7 key points which you're going to see discussed and practically presented in 3 use case examples now. Solution example number 1 is an Asia Pacific based customer for Petrosys. This particular customer was an existing user of Petrosys geoscience mapping and modelling, and their technical and GIS application landscape included Esri ArcSDE, the landmark OpenWorks R5000 technology platform, Petrel and some Paradigm EPOS environment. And the customer was using Petrosys in order to be able to directly map and model that information. The customer's environment also included at the beginning of the project an early incarnation of a PPDM-like database. And the customer had themselves assessed this and decided that they wanted to move towards a PPDM 3.8 based data strategy. And they had also assessed for themselves that the well data, both operated and non-operated, was this customer's biggest challenge and biggest opportunity for improvement. So Petrosys worked with the customer to implement a PPDM-oriented master database for well information. As I said before, ArcSDE was important for this customer, and the ability to share this master knowledge with the SDE environment was very important to them. And you'll see during this solution example and another solution example how we were able to publish that data so GIS technologies had access to it. The biggest challenge this customer had was with the aggregation and the management of different versions of well knowledge. There were many public sources of knowledge that the customer acquired and received regularly. They had their own operated data and wells which they had knowledge on, and they received and worked with a variety of different spreadsheets. So the core part of the project was really to implement loaders, routines and procedures which helped them to master this data, but also to manage the various versions of information. And in this particular project, the customer themselves took the well knowledge which existed in the open PPDM solution, used some existing technology that they had, and used that to populate the OpenWorks environment, and subsequently had existing data flows from OpenWorks and to Petrel, which they were able to re-leverage. in the solution example. So let's have a look at what we implemented. We implemented some desktop access to this master repository, some data loading, and also some web-based access to their master well knowledge. This is Petrosys, the desktop application that many users will be familiar with, and one of the important parts of data management is making data management familiar and intuitive and a natural part of workflows for our customers. So here we have a couple of 100,000 wells being displayed, remembering that volume of data is one of the challenges that many folks face. We see it integrated with some spatial data, some raster images, and also some permit and some lease information. So this data has come directly from that PPDM 3.8 master repository. And whether a person, be a data manager or a geoscience user, is interested in a very broad view of data, or they want to be able to browse and look at a certain asset level, the desktop environment gives them a quick way to do this and a quick way to see multiple wells and be able to browse, edit, or update information about these wells. So given the privilege, these forms will allow users to maintain that master data, or if they have a read-only privilege, to see that information. And you can see here different views of that data. A quick look at the well, some information about various locational knowledge, some data about the statuses of that well, the depths, key dates about the well, various flags about the type of well that we're working with, importantly some confidence, confidentiality and quality indicators about the well, and the ability to drill into different depths of data, be it tops, formation picks, etc. And as the user clicks around here, they can browse, update and investigate different well information. Of course, the user and the data manager need to be able to query and report this knowledge, and they also should be able to integrate it with data coming from various parts of the other project environment, which is possible in the desktop. If we wanted to query some knowledge, we would simply click on the well, click query, and we implemented some default and standard queries for the user where they're able to assess data, build up information about that, and then readily export that information in a variety of ways. And here I've exported that data to Excel. As I said before, it was important to the customer that we provide access outside of a Geoscience desktop and integrated with their portal environment. And what you're looking at here is the ability to access the well-based knowledge in a corporate repository from a web-based interface. Here I'm just going to search the entire database for well knowledge, and I'm returned a collection of wells that I may be interested in. And as I pick on a well, we're able to see different knowledge about that well. If I'm logged in and I have privilege, you can see that I have the ability to update, copy, modify, or manipulate information in that corporate view. Again, providing access to this corporate knowledge about our wells to different users. We're able to run different queries and searches. For example, here I might query for all wells where any formation tops exist. And now I have back a list of wells from that system, and you can see it's found 11,000 wells that have formation tops, and I'm able to see those formation tops and understand information about this in a configurable way. So for this customer, implementation of a master repository for well information. You'll remember I said that it was very important for this customer to move data into FDE and make that accessible in their GIS-oriented strategy. This was also important for our customer number 2, but customer number 2 was a seismic-oriented data migration project. Customer number 2 is a large North American-based organisation. They held their seismic knowledge, navigation and survey headers in a proprietary seismic database and had moved towards PPDM for their well-based data stores and wanted to do the same with seismic. The requirements that the customer had was to migrate the data. This customer also wanted a commercially supported user interface for the management of their 2D and 3D data, both in forms and in bulk loading. This customer, and as demonstrated here by this screen capture, wanted to be able to directly see the seismic knowledge once it had been loaded. And this was achieved by directly registering the data that was in the PPDM database in SDE to make that information aware to the Esri environment. And that this customer wanted to complete the project in 1 calendar quarter, which we were able to achieve for them. So let's have a little bit of a look at the way that the seismic component of data was accessible to this customer. If I open a different map here, I'm going to open up a map which is going to summarize some 2D and some 3D seismic knowledge from my corporate PPDM 3.8 data model. And if I just browse a little bit over towards this part of the map, we'll begin to see some seismic knowledge. You can see here that I have some 3D seismic, and as I track around on the different parts of the 3D seismic, I'm able to also interact with the detail of knowledge which is in the PPDM master repository. In this case, for Seismic 3D, there's storage of various source and remarks information about the update history, how the survey was acquired and the acquisition details, and the ability to capture various processing steps should they exist for the 3D survey. And as the user clicks around, the ability to manage, update, query, and browse, just as I did with the well knowledge, this seismic. The same also for a 2D seismic line, which is here, the ability to work with the seismic information and see the surveys, the acquisition, the processing, the data loading history, and information and access to the hard copy and digital assets which may be associated with that seismic. So very much the same with well knowledge. We were able to satisfy that requirement for this North American customer with the ability to manipulate the data once it had been loaded, but also the ability under file import and seismic to be able to use commercial tools and technologies to stage the data and load it into the system. As with well knowledge, we have access to this also in our seismic and our web-based systems, the ability to query and browse, just as we did with the well knowledge before this information. Solution example number 3 is actually a much smaller customer, physically in size and the number of assets than example number 1 and number 2. And before I go into what the solution presents, you'll notice, and I'd like you to take note, that the requirements and needs of small and big organisations are very similar. Obviously the scale of data or the number of users or the type of problem and focus may vary, but what small and big organisations want to achieve is very similar. For this customer, they were an existing Petrosys client. Their technical application environment incorporated Geoframe, Petrel and Kingdom. There are other applications, but these were core to their geoscience workflows. The customer was growing quite rapidly, meaning that they were acquiring new assets and new interests. They were increasingly operating more fields, and through discussions with the governments involved, their joint venture partners and assessment of their data workflows, they had decided that they needed to improve that situation. Working with us, they implemented a master repository which covered well, seismic, lease and permit knowledge within the organisation, much as you've seen already presented in solution example 1 and 2. What was different about this need for this customer is that they also wanted to be able to relate this master well and seismic knowledge to some existing assets and document systems that they had. This customer already had in place some SharePoint, some Microsoft Access, and also lots of documents physically existing on disk. And so they wanted to be able to relate this corporate knowledge about wells to the physical information and digital information that they had. This customer is a user of MapInfo in GIS space, but much like the Esri users, they were wanting to be able to take this corporate knowledge and be able to publish it and relate it. Importantly, aggregating data from many different government-received data sources, joint venture partners who were regularly providing and required to provide data to the customer, and various spreadsheet and operated knowledge. So much like solution example 1 and 2, we implemented well in Seismic as a master repository, and I'm going to focus on showing you how we worked with the asset documents and the loaders in this particular example. Here we have a much simpler looking map, and it's only simpler so that you focus on the assets, not necessarily the volume of data which exists. But if I click on a well, just as in solution example 1, I'm able to browse data and work with data. You'll notice at this point that the view of data that's been presented to this particular user and organisation is different. And so Petrosys is able to tailor the way that well or seismic or permit knowledge is presented. And this helps people to work with data in a familiar form and way that they would like to see it. If a user in this solution wanted to find data about the well, and they want to find data on disk, that being digital documents that exist, they are able to run an external routine that searched for that data, presented them a very simple web page that showed matching data, relating key attributes about the well that were in the corporate database with the data on disk, see a list of directories, and subsequently browse the data which may exist, and in this case a particular core image. Naturally, the same was a requirement for them for Seismic, and you'll remember in this solution case and example, the customer had a document management system based on access, I should say, and they're able to query that Seismic asset system and that well asset system and get back a set of known parameters and locations of data. And this is true of many document and library and information management systems like Documentum or Research or other systems that people have implemented. The ability to query those and relate the geoscience knowledge with that physical knowledge is very important to users. And here the user could click on the SegY as an image, or if there was actually some SegY, which there is in this case, you'll notice it's launching browsers and tools and technologies which are appropriate for the viewing of that type of data. But again, the ability to relate the corporate knowledge of the seismic and the survey to the physical information that people had on disk or in document and asset management systems. If I go back to dbMap, in the system implemented for the customer, if I were to search a well and click on a well, much like I have this Google Map link, which subsequently brings up a location in Google Map, that was used very simply to relate the existing SharePoint portal and publishing of information and the publishing of documents for the customer. So there was a direct link to that information made available. And as we were able to browse in the desktop environment, it's also possible to find the assets which were associated or to search the assets in their own right from the web-based system. Here, if I run a search of all assets which exist, the digital and physical documents, you can see that I can browse, edit, update, and maintain that knowledge as well. If I run an advanced search, I might choose to find all assets that have some sort of digital data which exists. And here we've got back some wells, and we can see that for this well, there are 6 digital bits of information known about that well and their well logs, and we can see the appropriate location. And in fact, it's telling me that it can't actually find this asset on disk. It's been moved or it's been deleted or doesn't exist. So a range of ways for the user to interact with their physical and digital data on disk. For this customer, the ability to bulk load well data regularly and to do it in spreadsheet environments, which was a place where they received a lot of their data, and flexibly into the system was a very important requirement, and it's a very common requirement across a lot of the customers that we work with. And here the user is able to manipulate data, see errors about loading, validate data and business rules, and push information regularly into their master repository. So again, here we've seen different aspects of the solutions which have been implemented, in this case for quite a small customer, but importantly the data management challenges and values and business objectives achieved quite similar to that desired by large organisations. So in summary, I've been able to show you today 6 or 7 key things that Petrosys is able to help with in the context of implementation of a master repository and the way that that needs to relate and integrate with project data stores. Hopefully I've shared with you some of the challenges that we see in organisations and some of the business values which are achieved, but by no means have I been able to share with you all of the knowledge and experience that Petrosys has. We would welcome an opportunity to discuss with you your challenges and share in more detail other solutions and practical examples that we've been working on. If you'd like to do that, please don't hesitate to send an email to info@petrosys.com.au. If you'd like to read a little bit more about Petrosys data management, there is some more detailed knowledge on petrosys.com.au under our data management heading. With that, I'd like to thank you for your time.